Hello, everyone. Welcome to the 11th data visualization session for the data mentorship program. If this is your first time you are watching the 11th session, again, I like to point to this part of the code where we write this to show you that you're watching the 11th session. Right, the data science mentor program is an accelerated learning cohort for folks who are getting started in data science. Very basic and fundamental stuff, so that you could gain competency. You can gain fundamental competency in the field of data science. What we teach is so fundamental, and we to add to that, we add mentorship as a service. Because in learning, you almost always need a guide, somebody to steer you in different directions and be able to talk you through difficult periods. So that's what the accelerated learning cohort and the mentorship as a service is for the data science mentor program. My name is Pablo. I am the founder, convener, and host of the data science mentor program. I am a data science professional, a data science educator for the past 4 or 5 years. And I'm here sharing my experiences with folks. Now, if you are watching this session, that means you're in the live session of it. That means you can feel free to drop questions in the comment section. You can feel free to raise your questions. And if you are watching a recorded session, then it means you have access. You can drop questions in the comment section of the live the live stream, if it was streamed live, or if you are signed up to the data science mentor cohort, you have access to our private Telegram channel where you can drop your questions, and an engagement will kick start. Right, so that's enough for the introduction. So today we are going to be looking at multiple subplots. We're going to be introducing multiple subplots using Matplotlib, the Python package, visualization package. This is the 11th session, so that means we have done 10 other sessions introducing different aspects of data visualization using the Matplotlib library, from very simple plots to line plots to color bars. I enjoyed the color bar session. That's the 9th and the 10th sessions. Very interesting. Check it out. You should check it out if you have access to this, and again, you can check if it has a live stream. If it does, then that's great for the public. If it doesn't, then please check out, then figure out how you can sign up for the data science mentor program. So today we're going to be talking about introduction to multiple subplots. And so what we're going to do is we're going to focus on the intuitions, right? So the first thing we'll talk about, subplots. Now, subplots allow you to display multiple plots in a single figure. So with subplots, display multiple plots in a single figure. Right, so that's what it does. It makes it easier. So it makes it easier for you to compare maybe different data sets side by side, break down complex data into smaller and focused views. It also makes it easy for you to show relationships between variables. Again, different contexts. Right, so again, all this thing I just said right now, I'll write them down so you can compare different data sets side by side. You can break down complex data, so you can break down complex data. You break down complex data into smaller, focused views. And then finally, you can show relationships. You can use that to show relationships. And when you show relationships, you're showing relationships between variables across different contexts. So that's one. Now the next thing, okay, let me make this a lot. Let me make this work in a way. So what I'll do here is underneath here, I'm going to add all right, so subplots. So this one makes it look, put some content. Yes, so you see this looks good. Then over here, I'll now come over here, right? Intuitions. Right, and this should make it look good. And then here, the question is when this is a question. We're going to talk about, there are going to be key concepts. Let me now talk about key concepts. But these key concepts is something we've talked about again, but re-emphasizing will not hurt anybody. So key concepts. Now, a key concept to what we're going to be looking at, one, key concepts with one, we're going to be looking at a figure, and I mentioned figure over here. You can see I mentioned figure over here. So we're going to look at figure. Now, a figure is the entire, the plot, the entire plot or the page where your plot is drawn. The entire page where the plot is drawn. That's one. Then two, we're going to look at subplots. The subplots, I'm again over here, talked about it here. This is over here. And so again, re-emphasis, right? So with subplots, the individual plots are going to be arranged in grids. So here, individual plots are arranged in grids. So when we say grids, we are looking at rows and columns. Then, finally, we're going to now be looking at axes. Now, so we axes, these are the actual plotting area for each subplot. So the actual plotting area of each subplot. Right, so now here we're going to be looking at labels, we're going to be looking at fixed data. So these are the things that we have going on here. So these are the key concepts we're going to be looking at here. Now, the next thing to ask is when is it necessary to use subplots? So again, to put this in perspective, good question. When is it necessary to use subplots? Right, one, to compare trends. So it's important. So to compare trends. Now, when we mention plots, one of the first things that will come to mind is time series, right? So you can plot different time series for different variables. You can plot time series for temperatures versus rainfall. And so you typically want to have them side by side, right? Then Another one is for something called feature analysis. Right. Again, data almost always has columns and features, and features, tell a story about the data. Now, visualizing the distribution of multiple columns in a data set is the same thing as a feature analysis, because you're trying to understand the different features here. So again, this is another thing here. This is feature analysis. And then then we have model diagnostics. Now you want to plot predictions. You want to plot predictions, errors, and residuals together. This is a machine learning. You typically want to look at you want to plot the actual prediction as against the prediction, or the prediction you need. So there's the actual prediction and there's the prediction based on the model you've built, right? And then there's the difference between the actual and the predicted, which are called errors. So you can use that to do that too. And then we want to see the same data in different formats. Excuse me. So this is called multi-angle views. So you want to see the same data in different formats. You typically want to see a scatter plot or a histogram together. So it is necessary to have this to be able to look at it from this perspective. Now, in this first part of what we're going to do for multiple plots, we are going to plot a few things, and then just to show what it looks like. In the second session, which is going to be in the 12th session, we will now look at another technical side to it. And then we can now look at some issues or some of the parameters that we'll be looking at. But for now, we're just going to look at what the subplot looks like, and then typically write the code just to make it make sense, right? So the first thing I'm going to do, I'm going to plot a basic subplot. Now, I always say this, right? Whenever I start off, I almost always act like this is the first time I'm writing the code. But if you have access to the notebook, you see that again, it's just typically, same old. We've written the import statement. So again, I'll write an import statement. So I'm going to import Matplotlib .pyplots as PLT, and I'm going to import NumPy as NP. That's the first. Next, I'm going to create the data. This is always the interesting part. I use NumPy to create data. So we're going to create the data. And what we're going to have is we're going to, as usual, we shout out to the NumPy routines from linspace, np.sign, np.cost, typically just allowing us to mix and match our data, right? So first, again, we have x, which is going to be np.linspace, and we're going to have 0 to 10 and 100 elements in here. Next, we have y, which is going to be np.sign, which we have x inside, and then we're going to have here, should I call it z? Okay, let me say z, and here it's going to be np.cost. And so this is what this is the data we're working with. Now remember, guys, two ways for plotting data. I always mention there's the object-oriented and there's the MATLAB style. So we always mix and match. What we're going to do now is we're going to use the object-oriented style for building a subplot, right? So what we will do is we would create a 1x2 grid of subplots. So here we're going to create a 1x2 grid of subplots. So first we're going to have fig. Now, interestingly, we used to have ax, right? But now we're going to create two of it. And so we're going to have, put this in a bracket here. So we have ax1, then we have ax2. And so in here, we're now starting out with plt.subplots. For that, plt.subplots. Just to check it out, it tells you it's create a figure and a set of subplots. Right. So now if you look at it, it says this utility wrapper makes it convenient to create common layouts of subplots, including the enclosing figure object in a single call. Interesting stuff. Right. So next I'm going to now say we're going to now have 1 and 2. And then of course we'll have the fig size, which is typically a tuple of what we want to have. Of the size of our figure. Now, next, we are going to now plot the sine wave. So we're going to plot the sine wave and the cosine wave, right? So that's why we always say, you know, mp.sine and mp.cos. So we're going to plot those. Now, first off, we're going to plot the first plot. So this is plot 1. Which is basically the sine wave. And so with this, I'll say ax1 dot plots. Now we're going to say x and y. Obviously, you can see this is from the data we're working with here. Just a bit. My annotator just acted up. So hold on. Let me deal with my annotator first of all, and then let me bring it back. So yes, so I think my annotator is back. So these are what we're going to be using. So now we already have x and y, and then of course we're going to introduce color, and here we're going to be working with red. Oh no, let's make it blue. That's the first. Now, because we already have our object, so our axis object 1, we can use it to now set underscore title. And so this one, we're going to basically call it our sine wave. Pretty simple stuff. There's nothing so deep in it, just to understand the fundamental of what we're doing. Now, this is the first one. So we're going to plot the second. So this is plot 2, which is our cosine wave. Now, with our cosine wave, we are now going to look at the next data. We're going to have x and z added. So here we say ax2. Again, remember this is what we're referring to here. Dot plot. So we have x and z. That's what we're going to be looking at here. So we have x and z. Now with x and z, we are also going to have a color, which is going to be red. I'll close that. And of course, x2 dot set underscore label. Is it label or title? The title. And then here we'll call this the cosine wave. All this is just for us to, you know, make sense of. It's just for us to make sense of using subplots. Now, another interesting thing we're going to use is something called the plt.subtitle, which is like the subplot title. So it's a plt.subtitle, right? Basically, adding a centered subtitle to the figure. Here, we are going to say, what's the best thing to use? The best thing to use to describe sine wave and cosine wave are their trigonometric functions. So we're going to say trigonometric functions. Right. And then we'll close this, and then we can now say plt.show. Now, at this point of taking this this session, you should understand a lot of what's going on here. So this is our object-oriented figure, object-oriented plots. So we already have set up our figure and our figure and our axis objects, right? And remember, if I come over here, you can see these are the things we're looking at: the figure, the entire plot. We see the axis, which is the actual plotting area of each subplot. Now we go on to plot our first data. It's going to be blue, and set the title. And then we go on to set our second plot, which is going to be red and is a cosine wave. And then we say, look, the title is trigonometric functions. So we'll plot. So you can now see what we have here. Now, it's pretty interesting to look at what we have. Now you can see that for an interesting thing, right? We can see how we put our figure here, 12 by 4. Some things are not in order. For instance, the trigonometric function here, you can see this isn't in order. A lot of these things we're going to, like, there's a way to reorganize them, but at this point, we are just going to be looking at, you know, what it looks like. So yeah, so that's the first thing we're going to be looking at. Hold on a bit. Maybe I can say, let me say font size. Can I put font size equals to 15? Look at that. So just so we know, but yeah, this is possible. So now this is, you can see like subplots. We have more than a plot. Just again, just to go back to the beginning, right? And it allows you to display multiple plots in a single figure. So we have a single figure, and then we have multiple plots inside. So that's typically what it is. Now, the next thing we're going to look at is we're going to look at something called grid spec. Now, again, these are just intros, right? These are typically intros, and we're just going to look at these intros and then, you know, go ahead to talk about them. And then in the next session, we're going to break them down into different ways, where we'll now look at why some things can be all over the place and how you can solve them. So let's go to call them grid spec. It is also known as uneven grids. So let's call this uneven grids. Uneven grids, which it has a nickname, grid spec. Because at some point you're typically going to have grids that possibly not in the same, they're not really in that same order, right? And so we're going to plot this. Now, before we look, we talk about that, we're going to import something called grid spec, right? And so that's the first thing. And again, there's going to be room at the rest of the session, like in the 12th session, where we're going to break a lot of these things down, right? So I started by saying from Matplotlib dot. Now you typically think I'm going for pyplot. No, we're not going for grid spec. Look at that, right? Grid spec, and then I'll import grid spec. So that's the first part of it. we have that set up. Second, again, just like before, we are going to set up we'll set up our figure and what we're going to do. So two things are going to be different, right? We are going to I'm just going to copy and paste this so we don't waste so much time. So first things first is we're going to have our figure 10 by 6, right? And then we're going to have the grids. It's going to have, like, with our grids here, we're going to look at a bunch of things. Our layout, where we place our subplots, right? And then we have different parameters that tells us the number of rows and the number of columns we're going to be using. And then we're going to also look at the width ratio and the height. So you can see that they look sort of like, you know, one way or the other looking different. So let me run this. Now, the next is we are going to plot different stuff. And this is where I'm going to calm down and write down the code so that I don't typically start to, you know, put too many things, just paste stuff. So the first thing is this is going to be our large plot, right? It's going to be our large plot. Now, I'm going to plot this. So we start with x1. So you see that we still have our axis figure detail still existing. So it's like we're calling it from the other place. Now we're going to use something that is new, right? That we haven't used before. Again, this explanation will be in the next session, but here we're going to have fig dot add subplots. This is it. So we add axis to the figure as part of a subplot arrangement. So that's what we're going to do here. Now we're going to use GS, which is what we've created here, the grid spec, and we're going to say for our grid spec, we are going to have 0, and have a slice. So it says there's a first part to it of what we're going to be working with. And then, yes, this is covered. So then next we're going to say x1.plot, and we're going to plot the data we have already. So we have x and y, and then we're going to label this. I'm going to call this sign. That's one. Then we're going to have x1.plot. And of course, we're going to have x, but this time we're going to have z, right? And we are going to label this cosine, so which means we have the sine wave and the cosine. And then we definitely give it x1.legend. We've seen legend before, we've used that before. Now, this is the first. Now, the next I'm going to plot a smaller plot, right? We're going to have a smaller plot. And yeah, so we're going to have a smaller plot. And typically we're going to make that plot different, right? So here, let me call this the smaller plot. Now here I have x2, and inside of x2, we're going to use fig.add underscore subplots. And inside, we're going to go for GS, which is our grid spec here, and we're going to go 1 by 0. Again, by the time we're done, we're going to see just what it is we're working with here. Then we're going to now say x2.hist. So it's going to be a hist plot. We're going to say what we're going to have y, and with y we're going to say we have beams. We're going to put the beams in 20, and we're going to say our color is going to be blue, and we say alpha. Remember what happens to alpha? If we have with alpha, we're looking at our transparency. So let's put it 0.7. We have x3, right? We have x3, which is going to be the third what we're going to be working with here. We have ax3, and with ax3, we're going to say fig dot add the subplot. And with our subplot here, we are going to go for GS. These are the grid spec, uneven grid, and we're going to go for 1 by 1. Work with me here. Please work with me here. Then we have ax3.hist, and we're going to have beans here. So now we're going to be using the Z, and we're going to say our beans is equal to 20. Our color is going to be equal to red, and then alpha is going to be 0.7. Seems like the code they're getting too much. It's not. Now, finally, we are going to have plt.subtitle. This is our subplot title. Now, what do we call it? Do we call it a grid spec layout, or let's call this a grid layout. A grid layout. Right, I think that works. Grid layout. Let's say font size will be equal to 15, just like I did the last time. Now I'm going to say plt dot type layout. Here, the plt dot type adjust the padding around the subplots, right? So that's what we're going to introduce this. So some adjustments will happen. Then plt dot show. Okay, here goes nothing. Come on. Now you see what happens over here. Really interesting stuff. Oh, it looks so big. Let's make it 10, and let's see if we can make this 4. Oh, all of this look, yeah. So you can see that it could be in the whole of the screen, right? But it could be bigger, just so you know, so we can see it, right? So now you can see what we are talking about when it comes to grid spec. We have subplots, but they're not all in order, right? So that means at a point we have different visuals. Now, the large plot is at the top, right? And then the following plots are now at the bottom, which is x2 and x3, right? And you can typically see how all this have been set up. Now, this is just the intro part to it, right? And I just want you guys to just have a sense of what it is. Now, in this next section we're going to be talking about a lot of breakdowns, a lot of things, a lot of moving parts that exist in this, a lot of moving parts that exist in all what we're doing, right? But in this intro, this is what we have going on. Now, what I'm going to leave you guys to do is I'll leave you guys to sort of like, take in a lot of it, right? And then, start to ask yourself questions. I'll drop questions that you want, maybe in the Telegram channel, but this is just the introduction. And my thought is, I want us to see just the beginning of this. Right now, any other thing that we want? So we've done like the basic plot, and we have an uneven grid, which is a grid spec, but a bunch of other things. We'll talk about it. There are some things that we can do. Maybe we're doing comparisons and all. For instance, you can see over here that we have just there's the independent X and Y axis. What if we don't want to do that? What if we want them to share access? What will happen, right? So there's a lot that we'll do, and hopefully we can get that done in the next session, right? And then, and we'll try to make it make sense. But this is the first 2 things we have drawn for subplots. And just to do a recap, right? A subplot allows you to display multiple plots in a single figure. And again, just to put it in perspective, the learning objective for this is learning to build subplots, right? Because at some point you will need to, compare different data sets side by side, break down complex data into smaller and focused views, and then find relationships, right? Because we're having context, we have different context for analysis. Now, to some things are in perspective here. First, figure, right, which is the entire page of the stuff we're plotting. The subplot, which are the individual plots that are arranged inside our grids as rows and columns, and the axis, which of course are the labels, the ticks, and of course the data. Now, typically for use cases, right, we are looking at comparing trends. Why would you use a subplot? For instance, in a real world application, you typically want to, if you're looking at stock prices, you want to compare stock prices. You want to compare maybe opening and closing prices for different companies or different companies in the stock market. In healthcare, you want to plot a patient's vitals. You know, what was it today, tomorrow, or right after they are taking some, serious drugs and all. So you just plot them side by side. In machine learning, you want, I mentioned this, which will be important, is this part where we're running model diagnostics, right? And where you typically want to visualize training versus your validation. Then multi-angle views, you typically want to look at your visuals from different angles. It may be in different ways. For instance, you want to see like a scatter plot and a histogram in the same spot, which is typically what we have over here, right? We have like a histogram and sort of like a line plot, so to speak. Right. So this is what we have for today. Take your time and watch this. If you're in the live session, just drop a comment or you can ask questions. If you're watching the recorded session, please feel free to still drop comments in the Telegram channel and then ask questions. But our next session, we are going to now do something a little technical. We're going to now break down parameters and find out why we have things like some things can be uneven, like why this, right? Can all these guys can this be organized better, right? The questions like this would pop up, right? Why can we share axis? Can we share this axis? Yes. X and Y axis, and if so, what kind of parameters can we use to do that? All right, so that's that for today's session. My hope is that it was pretty simple, and it's something that I just need you guys to consume. Right? Questions? All right. The absence of questions, let's wrap this up.